So I'm here at the historic Jodrell Bank Observatory, literally behind the Lovell telescope, with Tim O'Brien, who is Associate Director for Jodrell Bank and who is actively doing research on a day-to-day basis using this telescope. Although you're an astrophysicist by training, not necessarily just a radio astronomer, but you do use the radio quite often. So tell us a bit about the history and the early radar observations of the telescope behind us, the Lovell telescope.
So this telescope, when it was built in 1957, it was the world's biggest telescope. It's still the third largest steerable telescope in the world, actually. The first thing it did was remarkable, really. It tracked by radar the rocket that carried Sputnik into space at the dawn of the space age in 1957. But in fact, it was, it then got into this whole area of space tracking of both Soviet and American spacecraft right through the space race. But its real purpose was, in fact, to study the planets, the moon, the planets, the stars and the distant galaxies, which of course is what it's spent now more than 60 odd years doing. But
it really evolved out of World War II and Britain's involvement in the development of radar.
Yeah, I mean, the reason Jodrell Bank's here at all was because the person that founded the observatory was Bernard Lovell, and he was a physicist who worked on radar during the war, so he developed airborne radar. And at the end of the war, he wanted to see if he could use this sort of wartime technology to do something relating to physics. So he initially started to look for echoes, radar echoes from cosmic rays, and he came out here to Jodrell Bank, a place just south of Manchester, where it was quieter in terms of its radio interference environment. And he actually detected echoes from meteors, so shooting stars coming through the atmosphere. And it was that effectively turned him into an astronomer. So he went from being a cosmic ray physicist to an astronomer. And out of that grew this whole activity, from meteors to the moon, to studying Venus by radar, to the aurorae, and then way beyond that to exploding stars and to the distant universe.
Tell us briefly about the work that you were doing studying the recurrent nova.
Yeah, I mean, basically my favourite star, really, RS Ophiuchi, is a recurrent nova. So it's a binary star system. There's a red giant and a white dwarf in a close binary. And material from the red giant falls onto the white dwarf, builds up over time. And about every 20 years or so, that material has got thick enough, heavy enough, dense enough, hot enough to start nuclear reactions. And actually that causes an explosion on the surface of the white dwarf. The whole thing brightens remarkably, so we see it as a new star in the sky, and it chucks this material off into space at many thousands of miles an hour. And astronomers around the world, once this is reported, typically by an amateur astronomer who might spot it through their binoculars as a bright thing, we all get our telescopes onto it right the way across the spectrum. So radio waves is our primary thing here, but all the way out to very high energy gamma rays, this thing was observed. The most recent explosion we saw in August of 2021, and since then we've been using our telescope here and a network of other telescopes across the UK called eMerlin, and way out across Europe, the European VLBI network, to make radio images of the material as it expands outwards. And we're able to actually see that this stuff is ploughing through the wind of the red giant star, accelerating particles to speeds nearly the speed of light, and producing these copious amounts of radio emission that appear to be coming from sort of jets, but sort of protruding, sort of shooting out in opposite directions above and below the plane of the binary star system.
So what's amazing is this telescope was initially began construction in 1952, completed in 57, and it's still working today. And
as we speak, right?
As we speak, and this video doesn't do it justice. It is huge.
Yeah.
And it's amazing. And this is open to the public, so if you're ever in Britain, I suggest you come take a look. It's not just this one, but there are others as well. So thank you so much, Tim, for your time today, standing out here in the cold December rain south of Manchester at Jodrell Bank. Thank you again for speaking with us.
Thanks, Bruce.